Hello everyone. In this lecture or video, I'm going to show you a data set that was used by one of my student groups in previous years, and they use this secondary data and they use that for their group project, and they performed, a bunch of different analysis. So I'm going to use this data set to as an example to show you what you can do with your data, what kind of analysis can be done with your data. Okay, so first let me talk to you about let me describe to you about the data. Okay, what is data about? Okay, this is data on U.S. cities in the United States. Okay, you can see on the first column here. Okay, this is the file. I'm going to update this video to Blackboard so you can see. Okay, I think I'm also going to upload the file, the whole entire Excel file with all the outcomes, everything for you to see. Okay, first, if you look at the tab at the bottom here, the data is original data. It's the original data, the cities in this column A, state, right, crime rate, property crime, violent crime, population density, female male ratio, income per capita, etc. Right? Many parameters all the way here. The data needs to be cleaned a little bit, so I copy the data over to the second sheet called working data, working sheet here. It's same data, okay? I just reformatted it a little bit. So like here, I take out the dollar sign, so just the number. So everything here is number, okay? The cities you can see from Los Angeles, Chicago, Houston, Texas, Phoenix, Arizona, Philadelphia, San Antonio, San Diego, Dallas, San Jose. It turned out they actually got 5,000 cities. That surprised me. I didn't know we have that many. It's probably cities versus townships. So cities, towns, townships, so municipalities. Yeah. The total, if you scroll down to the bottom, you see last one is Lake Park, Georgia. And I don't know where that is in Georgia. Like Manchester, New York, Nelson, Georgia. I guess cities big and small. And this is Allergies, Georgia. I know this place here. I know this little town. It's a town. Okay. So for column A, there are 5,288, let's see, U.S. cities from different states. Okay, that's the first two columns. We move on to the top. There's a crime rate. Crime rate. Okay, that's defined probably by crimes per certain number of people. Maybe I don't know, it's 100,000 or whatever. Whatever that is. Okay. Then there's the property crime rate. Okay, property crime involving properties, personal properties or real properties. There's a violent crime. So the column E is a violent crime rate. And then there's a population density. There's a female versus male ratio, female to male ratio. So if it's over one, meaning there are more female than male in the city. Right? If it's under one, like Houston, Texas, is under one, so there's more male than female in the city. You can see some cities are over one, some are less than one. Okay, let's see if we find any big ones. Yes, this one here, Washington D.C. Uh, female to male ratio is 1.1, is among the highest. A lot of women working in Washington D.C. or living in Washington D.C. Philadelphia 1.11 also. Let's see if I have smaller ones, smaller numbers, less than one. Gee, not many. There's one here, Anchorage, Alaska. Okay? More men than women. And this one here, Reno, Nevada. right? 0.97. You can see most more cities have more female than male. Well, that's expected, right? Men do uh, live shorter, not as long as women. That we know for sure, right? Another one, Salem, Oregon. Okay. Another one, Garden Grove, California. Okay. There are some, cities like that. Okay. So that's a female-male ratio. And then there's the income per capita income per person, right? Person income is 31,032, 40, 20s, This data must be a little bit old, a little bit old data, but that's okay. We just use that to do our analysis. Because today, income per capita, I think it's definitely more than that. Okay. Let me see if I can move that a little bit, make it smaller so we can see more. This is median income per household. Median household median income. A median income meaning half of the families households have higher income than 54,000 in Los Angeles. Half have lower than 54,000. So Los Angeles is 54. Here is 71. San Diego is 71. That's pretty good. 196. San Jose and San Jose, California, Silicon Valley. You can select that, right? There's some lower ones, 44,000, Indianapolis, Indiana, right? And also this is education, right? I don't know how is it defined. We'll worry about it later, okay? That's not our major concern here, right? And then this one is poverty, percentage of poverty. People living under poverty, percentage, 20%, 15, 18, 14%, right? Then the population number, almost 4 million people in Los Angeles, 2.6, 2.7 in Chicago, 2.3 in Houston, Philadelphia, 1.58 million. Okay, that's the population. Then there's a female population. Okay, of Los Angeles, 1.9 million in Los Angeles, 1.95, 1.99 female, 1.95 male. Okay, that's why this ratio. The ratio of the two should give you this male-female ratio here. Okay. Then there is a household, number of households. Okay. Then there's population between 5 and 17, population between 18 and 64, and population with high school diploma, population with associate degree, population with a bachelor degree, master degree, doctorate degree. And you can see, like, let's see how many people in here. You can expect some high-tech cities probably have more doctor degree people there, right, living there, right? Then there's professional schools, people with professional school education, some college, high school diploma, black population, the racial composition, black population, white population, mixed population, other races. Basically, that's all we have, right? So that's the data. Let's see how many parameters. You can see the city 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, 30. 30 parameters. Yeah, pretty good. 30 parameters with 5,000 observations. So exactly what I was asking them for, or I expect them to have. Okay. So what commonalities can you do? Okay. First, when you get your data, sorry, when you get your data, you need to make sure you have the column heading here, right? In simple words, put it in one, abbreviate it as much as you can, right? Like a violent crime, right? Yeah, instead of violent crime rate per 100,000 people, right? Population density, just pop density. So use a shortened, abbreviated term or name for the column, right? And then other than this, I want to have all but numbers, pure numbers in there, no text in the middle, right? Make sure you don't have missing numbers. And then you have a clean working sheet, to have, right? It's good idea to have always for you guys to consider. It's always a good idea to have a copy of make a copy of this. This is a kind of working data. Let's call this a worksheet. Okay, I'm going to worksheet. That means this is one I'm going to work on, right? I'm going to paste it. Okay. Oops. What did I do? I'm going to undo that. Can I undo that? No. Did something wrong here. Hold on. Let me clear. Let's go to worksheet. Okay. I give the name of the sheet, right? Let me copy it again. Copy. Okay. And I'm just going to copy and paste with the special, with just the values. Okay, that's the values. Okay, so they should be exact same copy. So make it habit for you, so you do not lose original. Okay, you make a mistake, your original data, file is intact. Okay, have a worksheet here. Okay, so now what kind of analysis can you do, right? First, if your Excel file does not have it, you need to install something. Okay, first, if you go to home, you see home here, right? There's analyze data. Do not use this one. Okay? This is actually some kind of like artificial intelligence type of thing. So you can say AI type of thing. They analyze something for you. Let me show you again. Let's look here. Let's use that. You see here, they grab the data and they're analyzing that, trying to come up with something like a pivot table, the other things, right? That's the automatic. I don't need you to do this. Okay, this is under home, analyze data. Right, I don't need you to do that. Okay, I want you to do it manually. Okay, what you do is you see here, file, home, insert, page layout, formula, data. I want to go to data, and I'm going to use data analysis. I have it here installed on my computer already. Right? If you don't, you can always go to home, right? Go to file, go to options. Let's see. There's options, right? Options. And then once you go to options, Excel options, you go to add-ins. There's add-ins here. And then you should see, you probably don't have anything here, but over here you see this analysis toolpack called analysis toolpack. Since I already installed it, it's over here. If it's not installed on your computer, it should be under here. Okay, so you choose that. Choose that, and then manage is click go. You click go, it's going to install this analysis toolpack on your computer. Since I already have it, so I'm going to do that. I'm going to cancel it. Okay, so where is it? Then you come back to your sheet. You go to data. You see there's a data analysis. All right, that's what you have. That's what I want you to do manually to analyze your data. Okay, instead of using the packaged analytic tools that you just saw. Okay, data, right? You click on data analysis, a window pops up, right? What I need you to do is first I need you to do some descriptive statistics, like here. See descriptive, right? Descriptive, you click OK. And then ask you to put the input range of your data. It's grouped by columns or rows. The first is a range, right? I'm not going to analyze the cities or state name, of course, right? We're going to do this. We're going to start from here. Okay, I'm going to start from, let's see where it starts. It automatically select something. That's good. It automatically select from C1 to T30. I don't want to go to T30. I need to do more. So instead, what I want to do is I'm going to take this out and then click on here. So this one here to the C1, right? I'm gonna drag down. Or I can just go look at the numbers. Just keep rolling down. 4,000, almost there. 5,000, okay, 5,022.88. Then I'll go across to cover all the parameters. The last one I have is here, okay. That's my range. So it's basically C1 to AC5288. C1 to 5, has all 5,000 records here. The data is grouped by columns. That's right. That's good, right? It's not by rows, right? It's grouped by the columns. Okay. There are labels in the first row, so you're gonna click that. Labels in the first row, right? And then you need to have you can select your output options. Where do you want to put output? You can put output in the same sheet somewhere, given the range. But I would recommend you to do the same. Give them a name. Let's call it descriptive, right? Descriptive. I call it descriptive, okay? And you can do a new workbook too, but new worksheet is fine. It's called descriptive. Let's call it descriptive one, okay? And then you want to check a few of this. You want a summary statistic? Yes. Do you want a confidence interval? Yes. Default 95? Yes. And you want the case larger or case smaller? Yeah, we don't need that. Then everything is checked. Okay. Click OK. Then you see there's a descriptive one right here. So, and that is created, using descriptive statistics, right? What kind of descriptive statistics is being done? It calculates the means, see? The standard error, median, mode, standard deviation, sample variance, kurtosis, skewness, range, minimum, maximum, sum, count, etc. The count is 5287, right? Should be all same, right? And then for all the parameters, right? There's a crime rate, a property type, and all that all here. Okay, I think it's off by one something somehow. Okay. I don't know what's going on here. Okay, but anyway, so that's a crime. And once you have this, use a computer, use Excel to calculate your descriptive. But and also once you use some picture and tables, chart. I'll show you just a minute. Okay, that's one analysis you just I want you to do. Okay, descriptive. Let's go to the second one. Next, let's remember this is AC5288. The next one I want you to do is called correlation. Correlation. Okay, we can just leave it here. Because we're going to need that again. I need to select the range again. So I'm going to go back to where we were at the bottom here. Bottom of the sheet. Here we go. Stay here. Then go to data analysis again. And then I want you to try to go to correlation. See, correlation. Okay. Correlation, let's see. Yeah, correlation, right? You click OK. Then again, ask you to enter the range of data. When you do correlation from here on, same thing, same way, right? You can select everything. You can type or you can use cursor to select either way. I like to use cursor, just more visual, intuitive. If you just input numbers, you may make a mistake. So I'm going to select all these here. No need to do a correlation on date, state, or city names, right? So that makes sense, right? Again, same thing. C1 to AC5288, same as the first one, right? Also groups by columns, that's fine. And then there's a label in the first row. We click on that, click on the first row. Output range, again, output options, we want the new sheet. This one I'm call the correlation one. Correlation one. Okay. Again, that's it. Right? Then you click OK. Boom. You have a correlation table. Okay. Why is the half triangle? It's a right angle, right? Why is half triangle? Because you don't need this half. Because yeah, for everything here should be the mirror image of the bottom one. Because the correlation between x and y versus correlation between y and x, they're the same. So we only need half, right? Why are there ones along this diagonal line? This is because this is a crime rate. If you look at the parameters here, this crime rate. You see the advantage of having a short, brief name here, right? Here's your parameters, and here parameters in rows and in columns. The ones are where there's crime rate versus crime rate. The correlation of one variable with itself is what? Is 1, right? That's same with all the variables. That's why it's all ones here. When you look at this, I want you to look at something, look for something that's significant, right? Like this one here. What does this mean? I'm going to give a highlight here. 0.9903, almost a perfect correlation. Crime rate with the property of crime rate. That you can expect, right? If the city has a higher crime rate, it has a higher property crime rate, right? Does always have a higher violent crime rate? Not necessarily, but it's pretty high correlation, right? 0.68 is not bad, right? Does crime rate correlate with the population density? It's negative. It's minus, and it's also negative, meaning there's negative correlation. So it doesn't mean there's a higher population density, there is going to be a higher crime rate. So it's the opposite. So that's kind of interesting, right? So you can look at around this, look at something that's like in high, the correlation coefficient being high towards 1, closer to 1, either plus 1 or minus 1, right? Like this one, 0.88 is pretty high, right? You see what is this? Let's see. The income per capita with the income median household. Well, that's self-explanatory, right? So that doesn't surprise us, okay? What about this one? Education and income. Wow, this is a good one. I like this one. You see, income per capita versus level of education. Right? The higher education, more the education you have, the higher income. That's what we need to know, we want to know, right? And also this one is income and median household. That's also pretty positive. That's great. Right? So once you have that, I want you to look at that and look at the numbers as a larger than say 0.5, 0.6, 0.7, 0.8, especially 0.89, and see if it makes sense to you. Right? Let me see if we just pick a few randomly. Let's see. This one is minus 0.63, right? What does this mean? Income per capita versus poverty percentage of poverty. If the income is higher, the percentage of poverty, people in poverty is lower, is negative, right? That makes sense, right? And also the median income with poverty, of course, is also lower. That doesn't surprise us, right? And okay. And if it's smaller, like say here, like 0.03 or 0.02, we know the correlation is not that strong, right? If it's not strong, we're not that interested in that, okay? So I'm just gonna pick a few here. You can play with that. You can look at all these, find something interesting and see if it's intuitive or counterintuitive, right? Like this one here, you have some, here, oh yeah, here we have a whole bunch of high ones. Let's look at what this here. Population and also female population and male population. Okay. these are all higher, pretty high, right? That's expected, right? That's expected. Higher population, higher many things. The higher population, the higher black population, higher white population, higher mixed population. Yeah, you can see that, right? So all over here, most of these here are highly correlated. That shouldn't be surprising. This is highlighted. Yeah, let me give you a different color. So, okay, so you have a correlation now. That's the second one I want you to do. Okay, now let's go back to the data again. Worksheet. Next, I want you to go to data again, go to analysis. I need you to do ANOVA, analysis variable. I want you to do a single factor ANOVA. Okay, single factor ANOVA. First, you decide on which one you want to compare. Okay. For example, I think I want to compare the person. Wait a minute, is that right? Worksheet, yeah. I want to compare the. Uh, let's see. Hold on 1 minute. Do we use this one or that one? See, I don't want this to be in dollars. I'm going to take that out. Okay. I want to use this, and I don't need the cents, just dollars. Be good, right? I want it centered, the whole thing centered. Okay. So what I want to do is we're going to combine. Let's see. Look at the income, per capita income, this one, and across different levels of, let's see if we have any categorical variables here to look at. Let's see, income per capita, education. I don't know how this is defined. That's a problem with this. Household, number of household, age groups, education. I need to find the grouping variables, but I don't have that here. Let me see what I can do. Okay, hold on 1 minute. Bear with me. Okay, I'm going to, you're going to what? Looks like this is education. I don't know if it's a percentage or what, but we're gonna use this. Okay. I'm gonna look at the income per capita and compare it with different education groups, levels, academic groups. What I need to do is first I'm gonna take the data out, take the data out, okay? And then look at what I'm doing here, right? I'm gonna copy, go down, copy all the way down. Oops, over, back. Yeah, I'm gonna copy that down here, okay? And then I'm gonna click copy, Control C, copy. I'm gonna add a new sheet here. Or like, I'm gonna call that ANOVA sheet, ANOVA data, okay? And then I'm gonna just leave it here. So let's just paste it, okay? I don't need the ones in the middle, household income numbers, so I'm just take it out, okay? I'm gonna delete that, okay? Only have education number and the income number. I don't know why this one is not in dollar sign. Anyway, I'm going to get it back, okay? Make it dollar, okay? And yeah, let's take out the dollars. So we just use numbers, okay? We just use this, and I don't need no digits, no digits here, okay? Uh, this is something I want to do here. Okay, I want to sort education. I don't know how it's exactly defined, but I know this either the education, more education or less education. Okay? We can look at the number of the numbers. It can looks like it's like zero point 0.7, zero point 0.8, zero point 0.6, zero point 0.5, and some one. You know, there's some different numbers, right? I'm gonna rank this. Yeah, I'm gonna copy this again. I'm gonna copy that. Yeah, it wouldn't be a good habit to copy everything. Yeah, I'm gonna paste it over here. Oops, I'm gonna paste it over here. Okay, then I'm gonna play with this number. So what I'm gonna do is I'm going to uh, rank this, based on the level of education. Okay, based on level of education. So again, select the whole thing, whole range. Okay, and let's go back up. Okay, I'm gonna go to data. Right, there's sort. Right, I'm gonna sort it. Well, how do I sort it? I want to sort it by the column. Which column? Column J is education. Right, so I'm going to select J education. Okay, sort on the values. Yes, right, not on colors, of course. Values. And I want to go from the largest to smallest. Yeah, I'm going to do this way. Select everything, sort by education, cell values, large to small, and click OK. This is what we have. Oh yeah, here we go. Looks like that must be the, that's good. That's good. We look at it here. Hold on. Let me give the same number of digits here. Let me select that. Okay. Looks like this is education, must be education in years. Okay. Look at the 13 years must be for doctorate degree, 30, 10 for masters, etc. See, right? That's the all the people, you know, all 5,000 people, some with many, many years of education, some with fewer years of education. That's the numbers here. A lot of people with few years. That's like, I don't know why it's a point oh, point 0.5, but whatever, yeah, whatever it is. I'm going to leave that into different categories, okay? Let's say there's 5,000 of them, right? Let's say, I will say, let's say 5 years or above as one, okay? 5 year or above, right? That's one group, right? I'm gonna highlight this, okay? And then education, that's like all the 5 year to 13.78 years. 75, those people make, that person has a 13, almost 14 years of education with $75,000 income, okay? And this city, you know, has a 10 years education, you know, and then has 113 in the person per capita income, okay? And then from between five and let's see, five and let's pick a number to three. How about between 3 and 5? How about that? Okay, 3 and 5, that's one. Okay, we're gonna just highlight them. And the next one we're gonna between 3, 2.993, be below 3, and let's say and 2. Okay, let's choose that. Use that as a second group, another group. Okay, so we have the first group over 5. Then the next group under 5 till over 3. Okay, the next one from 2 all the way till yeah between in the 2s, right? And then the next group from 1.99 below 2 to over, let's say, over 1. Okay, over 1, keep going down. Where's my 1 coming to? Here we go, 1. Okay, and then here, from here down is 0.99. Okay, I'm going to lump them all in one. Oh, looks like there's so many of them. Let's go to 0.5. Just have another category, okay? I'm create different categories of people with different level of education. This time I'm going to go with 0.50. Let's put this way. Here we go, 0.50. Okay, over 0.50 right here. Okay, we use that as group, another group. Okay, let me see. Yeah, then that's another group, and then the rest under 0.50 is another group, right? So what kind of group do we have? We have personal income, okay, education between 5 to 14. That's educate one. That's one group, right? And then we have let's see, we do we have 3 to 5. Okay, 3 to 5. Here's another one, right? And next one we have 2 to 3. Okay, this is a small group. 2 to 3. And the next one we have 2 to 3. That's 2 to 3. Then we have something to 2, right? Is I think it's where did we cut it off? Yeah, 1 to 2, and then 0.5, I think, right? 0.5 that we look at. Stop. Here, 0.5, yeah, 0.5. So 0.5 to 0.5 to 1, yeah. Okay, so we have 1 to 2, and then 0.5 to 1, and then 0.5 below 0.5, below 0.5. The reason for that is because we want to, in ANOVA, we want to compare groups, right? Different groups. But I don't have, the reason I'm doing this, let me explain to you. I don't have, they don't have this in the data set, a grouping variable. I was hoping to have age groups or education groups in groups, but they don't have that. They only have these continuous variables. That's why I have I have to separate them, okay? So when I know what this is what I'm going to do, okay? I'm going to delete this so we can move this over, okay? So what I want to do is I want to see how many, for those people under how many observations are there for this for education between 5 to 14, right? I'm going to copy all this here, okay? See here, this is from 5 to 15, 14, sorry, 5 to 14. I'm going to copy that, put under here, okay? Next, I want to from 3 to 5, right? I'm going to select from here, right here. All these are the 3 to 5. I'm going to put it here under this 3 to 5. Okay, from 2 to 3, next one is 2 to 3. Right here, from here, there's 2 to 3. I have here, right, the 2 to 3. I'm going to put it under here, 2 to 3. Oops. Oh, what did I do? 5. I go to 2 to 3 again. Control C, I must have pressed the wrong key. That's 2 to 3, okay? And then 1 to 2. So go to 1 to 2. Here's 1 to 2, right? All the way, then lots of them. Go to here. That's 1 to 2, right? I'm going to copy it again. And then go back up here. Put them under 1 to 2. Boom. Next one, I'm going to save it. Save the file. Control S. 0.5 to 1. Okay? 0.5 to 1. Here. 0.5. There's lots of them. Here we go. 0.5. Gonna click Control copy. Back up here. Right. And finally, Control S again to save. Go to below 0.5. Okay, how many below 0.5? Just saving the file. Go down. Here we go. I'm going to select all these income numbers below 0.5. Okay, that's quite some of them over here. Okay. Okay, the last person has the education 0.05, the last city has 0.05, and then income only $5,600. So that's pretty low. Okay, so we're gonna copy that and bring back here and click here. Now with that, we can compare to ANOVA. Remember what ANOVA is about? ANOVA is for you to compare means across more than 2 groups. You can compare means for several groups. In our case, we have 1, 2, 3, 4, 5, 6 groups. We have 6 group of people, right? 6 group of cities, let's say cities, with their education numbers, okay, between 5 to 14, 3 to 5, 2 to 3, different groups, their education level, right? Different education level. And here the cities with the average per capita income. So we want to compare, see if they are the same or different. Intuition tells us, they got to be different, of course, right? We know that they're different, definitely different. But we want to do a test. How do you do the test? Now go back here, go to data, click on data, data analysis, go to ANOVA. We're doing a single factor ANOVA because just one factor, income, right? Single factor ANOVA. So we're going to click OK, income and education. So the data range here is from here. I'm going to select from here and all the way down. Okay. You just go with the highest, the longest one, the one with the most observations. The other ones with less no observation, that's okay. Fewer observation, that's okay. Right? We just go with the longest one. This one is the longest one. We keep going, going, going. Here we go. Right? Select the longest one. So that's the H3 to 2486. Okay. And then again, the group is grouped by the columns. Right? Is a label in the first row? Yes, there's a label in the first row. And alpha just use 405 default is fine. Worksheet. Let's call it ANOVA 1. ANOVA 1, right? Then click OK. We have ANOVA 1 here. You see ANOVA here. There's ANOVA data. There's ANOVA 1 results. How do we interpret the results? Okay. The result is, okay, first, okay, we have groups. 5 to 14 is group, 3 to 5 is another group. These are our groups, right? I have 6 groups here. I'm going to highlight that, you can see, right? And here are the number of cities in the groups, okay? Altogether should be 5,028. Yeah, here is 5287. So yeah, that's total, right? It looks like there are more cities in this group, 0.5 to 1. The next one is below 0.5. The highest earning ones is smaller, right? And this is the sum, this is the average, and the variance, okay? And then what's our result? What's the ANOVA result, right? The between group sum of squares here, within group sum of squares here, there's a degree of freedom, right? For both, there's a mean squares. This F ratio, F is 2800, pretty high, right? And the p-value is 0. Let me see if we can come up with some digits here. Is it 0 or more, right? Let's go with the more data. Yeah, it's still 0. Yeah, but a lot of zeros, meaning, and F critical is 2.215, so 2811 is way higher than that. So meaning there's a significant difference between people or cities with different level of education and their per capita income. That's the result from this data, okay? For your analysis, I don't care if your result is significant or not. All you need to do is to perform the analysis and then interpret your data. That's for your ANOVA, okay? Okay, we'll do one last analysis will be done, okay? The last analysis I want you to do is, okay, again, go here, I want to do regression. You can form or go to data, go to data analysis, oops, what's going on here? Let me save the file, what's going on here, it won't let me. Okay, let's go to data analysis, right? And you go down to the regression is somewhere in the bottom here, right? Regression here, and then click OK. When you click OK, you need to define your y input or your dependent variable. Okay, in that case, I'm going to use let's say I'm going to use the crime rate. Right, that's dependent variable. What is causing crime rate to go up? Okay, so you see, in doing that, we're going to collect for this one, for this run here, it's a C1 to C24. We don't want that. For this one, we just do that. We're going to go with the crime rate from here until what this last one again, to 5,200 something, right? Okay. Yeah, 5288, right? And what's your Y range? Y range is your independent variable. We want to know what kind of things affect the crime rate. Does income affect crime rate? Or education affect crime rate? Right? We want to see that, right? Or female-male ratio affect crime rate, right? And population density, okay? So what I'm doing is I'm going to select this here from that, and then also poverty percentage, right? Let's use these 5 here: population density, female-male ratio, income per capita, income median household, and education and poverty percentage. I'm going to use that to go, right? Go to where? Go to, that's F1. I'm going to just still copy the number from here. There, 5288, okay? And then we have labels, yes, right? Labels here. And the constant, you don't worry about that. The confidence level, 95%, that's good. New worksheet, let's call it regression. Regression one, okay? And you need this, so for autocorrelation, you need to select some residues, right? We can have a residue plots, right? We can do a line fit plot, standardized residues, yeah, normal probability plot. Yeah, you can just select a few of those, okay? Look, everything is fine, everything good, right? These are wide range, so dependent variable is crime rate, right? C. And then X range are the independent variables we pick the field, okay? Let's run it, see what happens. Click OK. Boom, we have crime regression done, okay? Okay, how do you interpret that? Okay, how do you interpret that? See here, let's look at the numbers. If you remember my lectures, you know R squares, right? What is R square here? R square in this case, highlighted 0.23, 23%. So you have a theory here. You have data. You want to interpret the crime rate. You want to predict crime rate, right? We pick the field. We pick the six parameters, right? The six parameters we will look at, right? Where are they? Right here. Population density, female-male ratio, income per capita, household income, education, and poverty, okay? And we look at that. You use those numbers, use those parameters, six variables. And then what we found is, right, we want to see if our theory is works, is predicting. It turns out our theory is not too good, right? Not too bad, right? 0.23. So our theory, our model can explain 23% of the variance in crime rate. If you think about it in real world, you know, if you have a model, your theory can explain 23%. It's nothing to be too joyful about, but it's something you can celebrate a little too, right? And then first, let's look at the regression model, right? Is it significant or not, right? I'll put some numbers here. It is significant, right? Because F ratio, the regression is F test, F statistics 263 is significant, right? That's overall, we have significant result, right? And then we look at our parameters, see what happens here, right? For that, we look at the p-values here, okay? P-values, right? P-values, intercept, you need to worry about intercept. First, population density, 0.007, right? Meaning it's significant, right? It's significant. And look at the coefficient, it's minus 0.71, okay? Female-male ratio, 0.7, right? It is significant, yes, it's also significant. So e to the 05, so it's very significant. This one here, income per capita, significant, okay? P-value is way small. All these, this one's also significant. Education, not significant. This one, poverty, significant, okay? And if you look at the ones, the coefficient, this one is pretty high. This one is not too good. These two are okay, okay, okay. These are not too bad. And this one is high, but it's not significant. It's also significant, okay. So what does this mean? Population density seems to be what? Seems to be is having you know, negative impact on crime rate. In other words, it's negative here, right? It's significant. It's less than 0.05, right? Meaning, yeah, the higher the density, the lower the rate. That's kind of counterintuitive, huh? Hey, that's what the number is, right? This one, so is a household median household income, right? It's negative, meaning the higher the household median household income, the less the crime rate, okay? Per capita income is not, wait a minute. Oh yeah, it's also good. wait a minute. Ooh, it's E.1. I'm sorry. Yeah, these two are not that good actually. They are significant, but the coefficient is low. It's e to the minus zero 0.05. I'm sorry. Oh, I made a mistake here. This one is also e to the minus zero 0.05. So this is 0.000007. So the four zeros there, right? So it's significant, but it's not a very strong correlation. Okay, the coefficient is too low. So are these two. So all these three here, highlight the yellow ones, they're very low, right? Female male ratios not is significant, and also it's actually the highest now. Okay? Interesting. Okay? Meaning the more female there are, you know, or female male ratio is higher, then the crime rate is higher. I don't know how to explain that. Yeah, we don't worry about that. Okay. So that's that. And basically, none of them is a very strong correlation. You can see that's 0.7, right? Yeah. Now this one is not too bad. Yeah. Poverty percentage is good, right? It's having an impact. Percentage of poverty. In other words, the higher the percentage of people in poverty, the higher the crime rate. That is in line with our intuition or our common sense. Okay, so that's how I want you to explain that. Right. So let's summarize, sum it up. Okay, you have a data set. I want you to put it in an Excel spreadsheet like this. Make sure your Excel has this data analysis tool pack, which is under data over here, right here, right? And then you're gonna perform, I want to make a copy of this working data, like a worksheet. I had a worksheet here. I need to do descriptive. I need to do a correlation, like this one. I need to do a regression, like this. And also need to do ANOVA, okay? That's what is required of you for this class, okay? If you have any questions, either put on a Q&A, question answering and the discussion board, or email me, or leave me a message, whatever. Okay. I think that's all I have for this class, for this lecture, special lecture just on using Excel spreadsheet to do statistical analysis. Okay. That's all I have. Thank you guys. Bye.